Dear students, welcome to the knowledge series on demand paging. Demand paging means whenever there is a page is demand from the primary memory towards the secondary memory. So how the particular pages is being transferred, it is that concept. Demand paging is a type of a swapping done in virtual memory systems. We have seen the virtual memory system is not the actual memory, but it's imaginary memory systems in the being created for the main memory with respect to the secondary memory. When we want to execute a process, we swap it into memory. That is between the secondary memory and primary memory. It is a swapping mechanism. In a demand paging, the data is not copied from the disk to the RAM until they are needed and being demanded by some program. That means whenever we are running a process, or let us take we are writing one program, and in the program all the functions is being splitted and saved in different locations in the secondary memory. So when we are executing that particular program, the CPU will look for the particular address and try to demand which are the files that need to be brought from the secondary memory to the main memory. So in that case, based on the address of that particular program's order, the main secondary memory will try to swap the certain files to the main memory accordingly. In demand paging, data is not copied from the disk to the RAM until they are needed being demanded by some program. The data is not copied when the data is already available in the memory. That means the whole program is not copied as per the requirement of the CPU or the operating systems. That particular program structure is being called. The swapper manipulates the entire process where the pager is concerned with the individual pages of process. The demand paging concept is using pager rather than swappers. That means based on the page locations, that particular page is being swapped. Following shows the transfer of the pages memory in a continuous disk. So that's what now it is a contiguous memory locations that is being shown here. In this one, the particular process is being swapped into this particular program, and that is being occupied. And if this one, once it is occupied, it is known as hit. And from if this particular file it has to move to this process, then once it is moved from here, then it is free. So this is a mechanism of swap in and swap out. Don't load the disk to RAM until required is being called by the demand. Based on the demand paging concept, the particular file is being swapped in. When a process is to be swapped in the pages, pages, guess which in the pages, guess which page is used to be used before the process is swapped out again. That means whenever you are swapping in anything, it is already also seeing that which file has to be swapped out. Instead of swapping the whole process, the pager brings only the necessary pager into the memory. This is to avoid reading into memory pages. That will not be used anyway, and decreasing the swap time and the amount of a physical memory needed. Swap in, swap out. Lazy swapper because it swaps the page only when it is needed. That is known as a tag is being a lazy swapper depending upon the needs. The secondary memory stores the process in the form of a pager, as I have already shared. Main memory is divided into frames. That is also conveyed earlier. When the page works is over in the main memory, it is swapped out to secondary memory. When any process needed by main memory, the pager is swapped in, and after the work it is being returned back. What is the advantage? It reduces the memory requirement, swap time is reduced, increase the degree of multi-programming. So many processes can be run without any memory issues. Disadvantage occurs a page fault. Page fault will occur, as I have already discussed, because in the thrashing is the one phenomena where this particular page fault creates. So this is a process want to load 2 and 3 is not available. So since the page 3 is looking for A and the page fault will if the 3 if the particular block 3 is not available, it will look for the secondary memory. If it is not available, page fault will. If it is available, then it will try to swap in. Page fault is whenever there is a requirement of any pages and that page is not prevented in the main is not present in the main memory, since it is not loaded from the disk to the main memory at that time, the page fault. Page fault means if the page is not able to recover and transfer. So this is the concept related to the demand.